Ladies and gentlemen, good afternoon and welcome to this short meeting that I believe is an anticipation of what we will expect for the conference in October. Thank you for being here. Thank you for being online to all the people following us on YouTube. My task is just saying a couple of words of the story of this conference, because several years ago we thought that we should have found a way to have a cross-sectional approach to science and to medicine improvement. We are all passionate about improvement in healthcare and in pediatrics. But one of the things that we suffer is that improvement is slow, and we need to find out other solutions for disrupting healthcare. We know that we have a problem of sustainability. We sometimes need disruptive discoveries, and for this reason we cannot rely only on usual science and usual research. Fostering innovation is not easy because it means finding out different people, get them together and let them work, which is absolutely difficult, especially for our profiles, especially when I think about healthcare. That's why we thought of a conference that was a mix of different things, different topics, different profiles, different speakers, and possibly also some fresh air from young people. And we decided to make a first attempt in 2017, and the conference was a reasonable success. We had, as you saw in the trailer, several attendees. And that was the very first attempt to have a conference fostering innovation in pediatrics in Europe. And we had a lot of participants from outside, even from foreign countries very far away. And we tried to make a second edition which possibly will be even better than the first one. So just a few words of what we expect to see. The agenda is divided into 4 different slots, in which you have a first part which is about advances in clinics and precision medicine, a second part about artificial intelligence, a third slot which is building the hospital of the future, and a fourth slot which is digital communication and digital therapeutics. All things that are coming and we are not very used to, and we want to discover and share experience with other people from other countries possibly. Don't forget that we have at the end of the conference a startup pitch event. This is instrumental to understand which is the value of involving startups in the process of innovation. You will listen to several presentations today telling stories about the application of this approach to discovery and innovation. And they are beautiful, believe me. One of the other things is that I always say that this is just a step in the process of innovation. This is not just a conference. We have a lot of things to do, and we want to meet persons that have the same motivation we have. We want to involve patients directly, even children, as you will listen to in a few minutes. But also, we should think about future educational programs, and this is something very tough. And once we understand that we should go very far away and touch different disciplines and specialties, we will understand that we should think of new educational programs. And finally, communication, because without good communication, nothing works. And letting people know that something happens is the only way to make a progress. We are actually part of a society, a scientific society, which is I-SPI, which is the International Society for Pediatric Innovation. As you can see from the logos on the right part of the slide, several hospitals are part of this society. Many of them are from US and very few are from Europe, just a couple or three of them, if I remember correctly. So I think we have the possibility and also the task to go much farther than that and try to involve as many people and as many hospitals as possible. And also, as I will tell you later on, to involve other stakeholders in the process of innovation. iSpy is organizing beautiful conferences. The next one will be in California in August, and has a lot of things to tell us, and we will be linked together for the next years also for sharing information and experience. Let me tell also that we were successful in inviting outstanding speakers from all over the world. We have speakers from the US, Canada, from Northern Europe, from Finland, from UK, and even from Italy, with a background which is very different from the clinics to engineering to Internet of Things to artificial intelligence, but even to the experience of the patients and patient advocacy, which is really beautiful. Finally, let me finally say that this is, again, not only a conference, but a place where finding and meeting innovators in pediatrics. That's my part, and with that, I leave you to the very first presentation that is actually about the experience of startups and the process of innovation through other people, and most of the times there are young people, for a special case which is rare diseases. Filippo Cipriani is presenting. Filippo is the head of the Open Innovation Unit at Sanofi Genzyme, and he will tell us some stories. Filippo, the mic is yours.
Hello everyone, can you hear me?
Yes, go ahead.
Hello? Okay, thank you very much. So, you have my slide, or shall I share my screen?
You better share your screen, but in case it doesn't work, we have your slides.
Okay. I have to add, I wasn't aware that I have to add the extension, so maybe it's better if you do it first, or, just me a second. Okay, so unfortunately, I cannot upload the extension of BlueJeans on Chrome,
Filippo,
so I don't have...
We have your slides. Just tell us when we have to move on, okay?
Excellent. Thank you very, very much. So, I'm glad to be here, and I will just take the next 14 minutes, just in order to keep the pace, to explain what is the philosophy behind the MakeToCare initiative and how can startups specifically encourage innovation when it comes to rare disease. Okay? So can I have the next slide, please? So, to cut a long story short, we started with a few considerations that are very known to people that work in the rare disease working space. So, altogether, there are more than 7,000 rare diseases that have been described in the scientific literature. Most of them, they show initial symptoms in pediatric age, and most of them, they have a genetic background. So the need is quite high, specifically due to the fact that just few of these 7,000 rare diseases have at disposal a specific pharmacologic treatment, okay, because research and drug development in this specific workspace is quite difficult. But however, disregard of the fact that a specific rare disease patient has or has not a specific treatment available, on a daily basis, we know as a company that has crafted their mission around patient life that patient needs more than just a treatment. They need solutions that can be mechanical, technological, can be software solution for their daily need. just imagine what you need in case of work, in case of sports, in case of study, in case of leisure time. So you have a specific disease. This disease is trying to impair your day-to-day activity, and so you need support. Okay, so this is true even more if you don't have a treatment, but even if you have a treatment available. So as Sanofi Genzyme, we ask ourselves, what can we do? And what can we do for the patient, and specifically as well for the caregivers that live the disease day by day together with the patient. So our solution was to create a sort of initiative that is a think tank and is as well something that supported and encouraged the development of this bottom-up patient-driven innovation. Okay. So, and this is including MakeToCare, digital manufacturing, and startup, just to name a few. Can I have the next slide, please? Again, we started as a contest in 2016 together with MakeToCare Rome. That is an initiative that I know that Massimiliano Colella will mention as a next speaker in a few minutes. And we tackled disability, all forms of disability, mental and physical disability. MakeToCare was born as a contest and is now developing in an open access report. Actually, we have issued together with the Politecnico of Milan 2 open access reports that are available for download. And what we have learned so far is that very young people, like 19 and 80-year-old makers, can be tremendous disruptive innovators, as well as patient association. Patient association, do not imagine patient association as it was patient association a few years ago. Nowadays, patient association, they explore technology quite often and quite deeply and want to do more than just disease awareness for their affiliates. Okay. And again, so this year we're going to celebrate the 4th edition of the MakeToCare contest, and we're going to have our final on October 6th in Rome. So if you are in Rome, please drop by, and you are more than welcome to attend. The next slide basically tells you that everything that we do when it comes to MakeToCare, it comes from our deep roots in patient observation. So this is the story of a father and his daughter. So the father goes by the name of Fabio, and the daughter goes by the name of Roberta. Roberta has a neuromuscular, progressive disease, but she's very, very young and passionate. And she wasn't happy for the braces, that is this support, mechanical support, that allow her basically to walk and to do rehabilitation. So together with her father, Roberta has developed, despite the very young age, her own brace. Okay. So basically that was the story number 0 for us, inspiring us to look at the patient when it comes to the best expert of what it means to live with the disease on a daily basis. So, and this basically were the 2 people that inspired the whole MakeToCare initiative almost 5 years ago. Okay, so the next slide is going to tell you what are the criteria that we believe we should look for when it comes to solution made by patients for other patients. So we need desperately to stimulate the creation of solutions that help to face unmet needs, solution that stimulates and improve the quality of life of patients and caregivers, We need something that is innovative, meaning not just new, but useful, together with something that is original and is adding something new what is already out there. We look forward to something that is already to a certain degree of maturity and feasibility, so it can be a prototype or can be already a product. We desperately need something that is scalable, because what is the need of a specific rare disease can be escalated and transferred to other diseases that are not rare that might have the same problem. Think about visual impairment. Visual impairment can come from a rare genetic disease or can come through age for diabetes, for instance. So if you find something that supports visual impairment, you can help not just rare disease patients, but many, many more patients. And we really treasure the direct involvement of patients or their patient association. In the next few slides, before I move to the report, I just give you a few examples of the finalists of the first edition. So we have very economic wheelchairs, specifically developed for sports. You have the idea in the middle by Nicolas Caporusso, the Big Glove, that is an input-output device for blind deaf people, okay, for communicate. The next slide, please. You have, for example, exoskeleton to support rehabilitation. You have wearable interface together with laptops or smartphones that allow deaf people, for example, to know what is going on in their own environment. So meaning if the doorbell is ringing or maybe there is something that is going on in their own environment. Next one, and we move for the finalist of 2017. We have again robotic arm in the right up corner. Again, you might have in the bottom left corner a set of garments that interact with the environment that can, let's say, take care of people with autism or diseases that are related to the spectrum of autism. Next one, please, and after I will dedicate the last 3 to 4 minutes to the report. Again, these are the finalists of last year. You have something for diabetes. You have something for people with back pain. We have seen over the years a lot of very smart and sometimes cheap solutions that can really easily implement. Okay, so let's shift gears now to the last, I think, 3 or 4 slides of my talk. So this is basically how the contest is working. It's very simple. So we are patron of the Maker Faire. Again, I said that there's going to be a process of selection of up to 12 finalists that have to give a 5-minute elevator pitch on the night of 16th of October in front of an independent commission. Okay. How we prize this idea, we encourage them with a business trip to Silicon Valley in which they meet other inventors, other startups, other makers, other, let's say, people with a vision. Okay, next one. And we talk about the contest because sorry, about the record, because the good thing is just MakeToCare is much more of a contest. MakeToCare is an ecosystem. So we realized that we have at least 3 different kind of actors out there. We have the patient and the caregiver system. We have the healthcare and research system, the hospital, who provides like the Bambino Gesù top-notch level of care. But in the bottom, from the bottom, we have this emerging a bunch of actors that are related to the making, to the digital manufacturing, and to the new way to do entrepreneurship. Okay. This will create a different, with the next slide, a different interaction between all these three bunch of actors. For example, if you have a patient that relates just with digital manufacturing, you have what is called advanced do-it-yourself system. That are solutions that, in my opinion, might be sometimes dangerous because there are no direct medical coordination from an healthcare practitioner that can tells you if what you are doing is right or wrong from the medical standpoint. You can have medtech system that is a solution, for example, that help hospital to improve the skills of surgeon, for example, with 3D printed organs. And you have what is the standard interaction between patient and hospital, that is what is called public community innovation system. When we relate to the MakeToCare, we want the equal representation of all the systems. So we want the research, we want the doctor, we want the patient, we want the patient association, and we want the digital and the e-health system represented. So this is what we have, next slide please, we have mapped in Italy, and this is what is the MakeToCare 2.0 or MakeToCare Square that is described in the report that has been issued a few days ago and is available on the web page www.maketocare.it. And basically, this system is now embedded in a policy level regulatory system in which you have incubators, you have accelerators, you have entity that gives you the CE mark, that give you the medical device mark. So we are now understanding how to make the idea that we have mapped now in Italy more easily progressing towards the patient. So if we go to the next slide, please, you will basically see, next slide, please. You will see what I mean. So we map.
We can't hear you, Filippo. You there? The fortune is that the presentation was at this end. Filippo? We can't hear you. However, let me say how amazing is this story, because one of the things that we were thinking is how to link to an ecosystem like the one you're discussing and you're describing in your presentation. You know very well that we are trying to make something that is very close to this idea from the point of view of healthcare and hospital. Did you get back your connection, Filippo? Can you hear me? That's a pity. However, I know that was one of the slides. Yes, you're back.
Okay, sorry. I'm back to business. So I just want to wrap it up. I give you the flavor. Okay, so we have mapped together with the first and the second report 150 projects, of which 56, almost one-third, are by all means part of this MakeToCare bucket in which all actors are. Meaning that we truly believe that there is a very bright future that takes idea from the patients, and we now have to find a regulatory framework in order to bring that solution to as many people as possible. So that is going to be my take-home message.
Great. Thank you. A round of applause to Filippo. Thank you so much, Filippo. We will talk soon because we have a lot of things to make together, hopefully. And we're looking forward to meet you at the conference because you will be personally involved, right? Thank you so much.
My pleasure.
Thank you, Filippo. So, okay, we will move to the second presentation, which is a presentation about human-machine interaction. The presenter is Fanny Ficuciello. Fanny is an engineer. She's from Naples, and she works at the University of Naples. By the way, Naples is the place where I got my degree at a university, and that's why we have a strong link. But Fanny works in a group of people dealing with the relationship and the usability of machines. This is very important because of different tools that we are going to use, or we already use, like robotics, surgery, intensive care, and other things. I'm looking forward to the presentation of Fanny for understanding more. Fanny, we have your slides. We go with our copy, which is maybe better.
Maybe I can share the screen if you prefer. I can.
Okay.
It's better for.
Okay, let's try. Okay, you try to share the screen and see. Because I thought your slides are very heavy, and that's why I was thinking.
So it is fine. Can you see my presentation?
No, we can't see your presentation, so that we got your presentation and we project your copy, which might be better. You just tell us when you want to move to the next slide. Here we are. Go ahead.
Okay. So first of all, thank you very much for the invitation. And yes, I'm a mechanical engineer working at the University of Naples, Federico II. And recently I was involved also on a surgical robotics project. So first of all, I would like to present my group. I come from Prisma team. So this is a very old group working in robotics in different fields, so starting from industrial robotics, aerial robotics, up to assistive robotics. And so some of us, so some researchers from Prisma team are also involved in surgical projects at Icarus Center. So Icarus is an interdepartmental center. Can you switch on the next slide? Can you hear me?
Yes, go ahead.
Okay, so if you switch on the second slide, you can see there my team. So the picture on the top is represent the Prisma team. And the picture on the bottom, some people working at Icarus Center. So Icarus is an interdepartmental center for advances of the research in robotic surgery, and collects School of Robotics, of Engineering, and the School of Medicine. So we are actually cooperating with the surgeons in order to share our research. And as roboticists, we are trying to bring our expertise in robotics, that is mainly on modeling, control, so force, impedance control, visual servoing, mechatronics design in surgical robotics. So if you switch on the next slide, here we can see our facilities. So the facilities that we have in the Icarus lab. And actually, the topics of our research that is mainly focused on the development of new force tactile sensing devices and new control strategies to improve the autonomy of surgical systems and to improve the manipulation and the interaction capabilities of surgical systems. Then we worked also on simulation of soft rigid contacts and on the development of new surgical tools. So our skills, as I told before, are on modeling, simulation, feedback control, and mechatronics design, etc. So in our lab we have the Da Vinci research kit, that is an old version of the Da Vinci robot working nowadays in hospitals. So that is the Da Vinci Xi. So our system is the oldest version of the 2000, so in 2000 years where the robot was working in hospitals. And actually we have an open version. This means that we have an open controller that we buy from Johns Hopkins University. So actually we can open the system and we can skip the telemanipulation control. So we can control the system as a common robot. And so we are doing research on Da Vinci mainly, and we are one of the 33 labs all over the world that received this donation from Intuitive Surgical, because our excellence in so our research is focused mainly on minimal invasive robotic surgery, but we have recently also started some projects on robotics prostate biopsy. Okay, so if we switch on to the next slide, here I have so represented on the left the Da Vinci robot that is the open platform that we used, and this is the Da Vinci Xi on the right. So actually during the years we got several improvements, so more degrees of freedom of the tools, so improved precision and perception and control, in particular perception because vision was a lot improved. But despite all those improvements, actually the control paradigm is still on telemanipulation. So basically no autonomy as this. And actually, even if we know, so this robotic system improve minimal invasive surgery because of improved precision and tremor filtration, etc. Actually, there are also some drawbacks because the surgeon, the only sense that the surgeon has is vision. So the surgeon has lacked the sense of touch, and also has to move in narrow spaces, and actually a mental transformation between visual and motor coordinates frames is still needed. So basically some improvements can still be obtained, and we have a lot of clinical motivation to improve the interaction. So not only patient-robot interaction, but also surgeon-robot interaction, because if we talk about Da Vinci system, actually we have a double interaction of the robot with the human. So one is the interaction of the surgeon with the master console, and another one is the interaction of the patient with the slave robot. So actually we need very precise movements in sub-millimeter workspaces, and this is the case of retinal microsurgery. Other reasons are, for example, in neurosurgery, orthopedic surgery, usually the surgeon moves in very dangerous areas, so some areas should be strictly avoided. And also there are some systems, especially for micro surgery, that where actually the human operates at the limit of its own capability. So basically we need very precise movement. So actually it is not easy for the surgeon usually to teleoperate those tools and perform like suturing or other very delicate interventions. So basically, what is our contribution? So we have concentrated our effort. Are you feeling my switching of the slides? This is a question. Can you hear me?
Yes, absolutely.
So are you following the switching of the slides?
Yeah. Do you need the slide where the telemanipulation paradigm? This is the current slide.
Okay, sorry. So you have to go on.
Okay.
And switch on motivation. Okay,
yeah.
Sorry. And again, you can switch on the next slides, limitations in interaction manipulation. So here in these slides, I highlighted the topics that the aspect that we are trying to improve with our research, that are the lack of sensory feedback, so lack of dexterous tools, and also challenges in control those devices. So actually, when we talk about autonomy in surgical robotics, we have to be very careful because an error can be really dangerous, and so until now the solution is that the surgeon has always the control of the system, and the only control paradigm until now for most of the robotic system is the telemanipulation. So we can switch on the next slide. And here I am showing some examples of tools of the Da Vinci robot. So actually, why it is so difficult to put sensors in those tools? So why the Da Vinci robot does not have force sensors? So we have different reasons. Basically, there are some devices, so some tools that are very small, and it is not easy to put sensors inside. Moreover, they have to be disposable. So basically, we have to use very cheap sensors that then can be replaced as well as the tools, because as you know, the Da Vinci tools has just 10 life each Da Vinci tool. And then during an intervention, a lot of different tools can be used. So we can switch on the next slide, and here we can see a video of one of our work. So here our proposal, so our solution is to develop a sensor that can be placed at the tip of the trocar. So the trocar is the cannula where the tools goes through and goes inside the body of the patient. So the idea is to use actually formulas and models in order to reconstruct the interaction forces between the tool and the human body measuring the interaction forces of the shaft of the tool with the tip of the trocar, where the sensor is placed. And we also find a solution to give back this information to the surgeon. Actually, this is we used augmented reality, so we imposed an arrow on the screen that actually represent the direction of the force, of the interaction force, and represent also the intensity, using the length of the arrow and using also the color of the arrow. So basically the surgeon, by looking at the screen, can understand how much the forces is high, so how big is the force that is imposing to the thread in this case. And this is really important because they actually provide us this feedback that they have sometimes difficulties in understanding when the thread is going to break. And as you can imagine, if this get broken, they have to start again all the suturing process. Okay, so this is one of our contributions. We can switch on the next slide.
Fanny, we are on the slide where we have two cameras trying to make a stitch into an incision. And you are 2 minutes left.
Okay, so I try to speed up. Okay, so actually we also developed new tools to provide more dexterity because now the tools are just composed of two jaws that compose the forceps. So here the idea is to put an extra degrees of freedom in this needle holder in order to replicate the in-hand manipulation to reorient the needle. And this is very important to avoid stress and damage to the tissue. So actually here we build another tool that increases dexterity. So we can switch on the next slide, and here we can see another tool that we built within the Musha project. So actually here we worked really in strict cooperation with the surgeons that provide us all the requirements for this kind of tool. This is a reconfigurable tool with 3 fingers. So we have basically developed a 6 degrees of freedom device that has acceptable dimensions that can pass through the trocar and that can grasp the objects, and so in this case are not objects but can grasp part of organs, and also the tool has tactile forces on the tip, so we can also feel the force. This is very important because we can use the tool also as a sort of a tool to measure, to have a map of the stiffness of of the tissue of the organ to understand if there are some, cancer or some problems in the tissue. So maybe I can control the video and try to speed up this video to let you to see basically. Okay, so here can work also to understand the stiffness and to diagnostic some tumors on. Can go on with the next slide. So here is represented our contribution to autonomy, so to improve the autonomy of those systems. So here the idea is to build, with the help of the surgeon, some virtual walls. So basically, using the trocar force sensor, the surgeon can plan points that then can be interpolated by the system autonomously in order to build some pattern that the system should follow. Okay, so basically here the idea is to build some trajectories where the system is constrained to stay. And those trajectories can be built in collaboration with the surgeon. So basically it's the surgeon that plan those points using interaction with the environment. And this can be very useful during this section, so to be more precise. So, in the next slides, I'm going to show another work that we did for needle grasping optimization. So here the idea is to again use force fields or also virtual fixtures, as we want to say, in order to grasp the needle in an optimal way. So actually, what is the problem in grasping the needle? So if the needle is not grasped properly, during the interaction with the tissue, so during the execution of the part, it can be necessary to reorient the needle, and these of course need to perform extra action. So basically, in order to reorient the needle, usually the surgeon should use also the other hand and perform a sort of regrasping. So the idea is here to try to avoid this issue in order, and this can be done by grasping the needle in a point, in a particular point and with a particular orientation, such that we can avoid problems during the path. So this is done actually exploiting some cost functions that are known from grasping theory. So this is another example of how we can bring and transfer our expertise from grasping and manipulation, robotic manipulation to surgery.
Sorry, Fanny, can you go fast, because actually we're out of time. Sorry.
Okay, so this is the last video that I show you. So here basically we use vision in order to build again some patterns where to cut, and the idea is also to adapt the virtual fixtures to displacement of the target, that in this case is a polyp, so a colorectal polyp. Actually, the concept that we used is the same. So first of all, we plan using vision now, not interaction forces, a trajectory, and then we build a force field in order to constrain the tool to stay on this trajectory. So I'm concluding by highlighting that actually in order to improve human-robot interaction in surgical robotics and autonomy, actually we have to act on different aspects that are not only the control parts, so the control strategies, but also the development of new tools and sensors for those surgical robots. So thank you very much for your attention, and sorry if I'm late.
No problem. Thank you, Fanny. Fanny, thank you so much. I think that this message is very technical and mostly for engineers, but actually we got a take-home message, which is we may customize all the functions that we have with this kind of robotic techniques. And this is especially valid for surgery. And we will have a lecture about robotic surgery in our conference in October from a group from Cincinnati. And the idea is not only customizing this kind of things for pediatrics, because, you know, children are very small, and this is a problem for dexterity and other things, but also adding some other accessories like artificial intelligence may be a very interesting perspective. Fanny, thank you again so much, and I'm looking forward to meeting all the group in Naples. Thank you so much.
Okay, thank you to you. Bye.
Okay, I'm going to say a couple of words about one thing that we will try to launch during the conference in October, which is the Rome Manifesto. Professor Dalla Piccola actually launched this idea, thinking that we have to follow some principles that are in some way under the processes that we have for fostering innovation. And we are in the position of trying to promote this kind of principles, and that's why we're drafting this manifesto. But let me tell you a couple of reasons why we're trying to do that. One of the things that you may have got even during the presentation of Filippo is that we live in an environment where innovation is completely given to a number of different stakeholders that are completely disconnected. We jump from one place to another, which is startups, companies, IT, ethics, regulatory, and other things, without a linear fashion and with no standardized process. So one of the problems that we're trying to address is making a single platform where all the resources are on the same level and where the process might be followed from the beginning to an end. This is something we're not used at because, you know, physicians and researchers are mostly used to the process of research, which is completely different because this is mostly implementation of ideas or discoveries. So how can we try to promote the actions in the process of innovation? One of the things is trying to identify specific steps, which is solution matching first. We start from clinical needs that may come from physicians or from patients, and we try to understand if there are ideas coming from different places, even from the work environment, sometimes from startups, sometimes from companies. But we want to avoid the usual logic that is once you have a need, you just shop. Because actually, ready products on the market might be not exactly what patients and physicians need. Once you've got the solution match, you can try to get to make a step further. After that, if the idea is, for example, just an idea, you may go to prototyping, which is something we're not very used to do again. And with the help of other stakeholders, namely startups or companies, you may come to a prototype and trying to make a validation of the acceptability of this product. I know many startups, for example, that most of the time stop just because they didn't check the acceptability of their product. This is a very important step for understanding if this is exactly what the people and the public needs. After that, we are ready to make the final steps, which is validation, which is mostly a research study, because we want to understand if something works and does not harm anybody. And once we complete this process, we believe that the object, the product that we have got in our hands is much more appealing for investors and the market. And we're not very used to do that, and we need partnerships. And that's why we're trying to imagine a platform where all these things are together. what are the activities that we may trying to envision for such a partnerships? We want to be, we want to foster ideas for offering to the market some solutions for improving healthcare, especially in pediatrics. But also we want to address some of our ideas using grants from the usual sources of funding. We want to also improve the educational paths. Again, this is a topic that will come out very frequently in our discussion. We feel like we need something that is not actual in our current politics and procedures for education. We must learn a lot of things that we don't know yet. And this is based on some simple principles. One of them is interdisciplinarity. We must talk each other with other disciplines. But we are also making an exercise which is actually trying to make priorities, because we must learn to make better questions, and we must learn to assign right priorities, because sometimes we fall in love with beautiful ideas, but actually we don't check the priority for our setting, our hospital, or for the public at large. This is one of the things that we want to address. The manifesto will be addressing some of these concepts, and this is something that is really obvious in some ways, but you can understand that we are very strongly focused on ethics and openness at the same time, because we believe in the possibility that innovation will be a progress for everybody, not only for actually the people inside a closed environment. And let me also tell one of the other things that I hope you will notice in one of the next lectures. Let open the doors to patients. You can't understand how amazing they are, especially when you involve directly children in the process of innovation. They come out with beautiful ideas, and sometimes they are very fresh, and you didn't think about that. And this is absolutely one of the things that we want to make. So, having said that, and having said you some, given you some sense of curiosity about this document that will be drafted and launched very soon for involving as many stakeholders as possible, let me move to the next presentation. The next presentation is about 3D. And this is something that we have developed directly in our hospital. Luca will present some of the things that he has helped to do. Luca is an architect, and it's not actually obvious that an architect works in a hospital, but what he did maybe justifies a lot of things that you may think while waiting for his presentation. Luca, please.
Thank you, Alberto. Thank you, good evening all, and thank you for attention in advance. I'm Luca Borro, and I'm 3D specialist in Bambino, Gesù. I'm dealing with the use of 3D technology in medicine for biomedical application. I'm here to replace my colleague, Dr. Aurelio Cecinaro, radiologist and head of 3D lab, that cannot be here for urgent commitment in clinical department. With this presentation, I want to show you what is 3D technology and how it can be applied to the medicine for the patient's health. In the next 8 minutes, about 8-10 minutes, we will go to know the most important project that we have done and that we are working on in terms of use of 3D printing and 3D technology in our hospital. Okay, I hope that the video goes on. Okay. There are 3 questions that are important to frame our field of application. The questions are what, and where, and why. What, because what is 3D technology in medicine? Is a technology that allows us to have a realistic 3D reconstruction of patients' anatomy from radiological images or from 3D scanners tools. 3D technologies in medicine allow us to design also new personalized or custom-made medical devices. where this technology can be applied in the hospitals, in particular in radiology departments and in 3D lab departments. And but this technology can be also applied in research laboratories and in private medical center, for example. Why? Because this technology is a tool that brings many improvements to clinical practice, for example, improvement of anatomical knowledge, especially in complex clinical cases, and it is important to obtain a surgery time reduction and to improve doctor-patient communication. Okay, these are the application, the most important application of 3D technology in medicine. The most important application are 3D printing, virtual reality and augmented reality, finite element analysis, and bioprinting. In this slide, I can show you our most important application in complex surgery. What you can see in this video is a planning of a multidisciplinary complex clinical case, the separation of two thoracopagus conjoined twins that were successfully operated from the teams coordinated by team of Professor Alessandro Inserra. You can see the liver surgery, the planning of the hepatic resection, and in this video you can see the 3D printing of the rib cage of our patient in thermoplastic material. For example, this is an packaging process for obtaining 3D printing. These are the rib cage of our patient in thermoplastic material, PLA, polylactic acid, and now you can see a more complex 3D printing structure, like as entire structure, anatomical structures of our patients with organs inside their transparent resin, and after this intervention, we did another conjoined twin separation for other two similar patients, but with the fusion in the sacral tract, and now we are working on another complex clinical case of two craniopagus conjoined twins. What are the advantages of use of 3D printing in medicine? First of all, reduction of surgery time. Our experience in the last 3 years leads us to confirm that one of the most important advantages that we have with 3D print technology is a reduction of surgery time. For example, for maxillofacial surgery, we can reduce the operation time about for 40%, and for general surgery about of 30%. Moreover, the use of 3D printing increased the safety in the surgery with an important reduction of hospitalization times that for our patient, for our pediatric patient and for family, it translates into an increase of quality of life. Another two important applications of 3D technologies are virtual reality and augmented reality. I will not stop too long on the meanings of this technology. I think that you can rewatch this presentation on the web in the next days, and I go directly on the next slide, where I show you an example of a virtual reality application. We've developed this application 1 year ago, and we are still continuing to develop it. What you are seeing in our patient's heart, and the two hands that you can see on the screen are the virtualization of my hands. With this application, I can control the 3D model and can drag it in a whole direction of the space with simply contacts from my hands and the hair. As you can see, I can show and hide some parts, some anatomical parts of the model, like as a aorta, pulmonary arteries, or left and right ventricles or atriums. And we can see the section of the heart, like if we are inside the heart, for better understanding of heart anatomies. Moreover, we can scroll the 2D radiological images to see the 2D plane of the anatomy at distance. We can control the scroll of 2D dimensional radiological images with the hands that go up and down, like as you see now. This is my hand that go down, and the CT images go down with my hand. Okay, here you can see a basic application of an augmented reality app for mobile applied to the clinical case. This case is an important case that regards our patient with an important arrhythmogenic cardioleukomyomatosis and myocardium scar. What you can see here are the images recording by a simple smartphone that point to the cardboard, the black and white cardboard that you see, with a simply code or general graphic code on the cardboard. When the smartphone points to the cardboard, on the screen appears the 3D model of the patient with some anatomical details like a lipidic formation in yellow and a scar of myocardium in red. With the movement of the smartphone in my hand, we can enter inside the heart virtually. We can virtually enter inside the heart and look around the lipidic formation, like as you see in yellow, and the scar of myocardium. This is a very basic application of augmented reality in medicine, but it was very important during the radiofrequency ablation procedure in operating room when the cardiologist considered it appropriate to consult these images to better understand the cardiac anatomy of our patient. In conclusion, I want to leave you with these images. You are seeing the 3D bioprinter in our research laboratories. This printer can print biologically active materials, and I think that is a very revolutionary technology for future. What we are printing in this video is polycaprolactone, that is a very real promising polymer that can be reabsorbed by our body in about 2 years. This polymer can be used for print scaffold for cellular culture. Thank you.
Thank you, Luca. You now can recognize why we hire architects. It's not for rebuilding something, but just for doing things like that. We have some time to make some questions, maybe. If you have some questions, I'm not sure that everybody is still online from the previous presenters, but actually, if you have a burning question, this is the right time to make it. Any questions, even for Luca? Because actually, one of the things that he has been describing is that there's an evolving word in the application of this technology into the operating room and other things. And what Luca is doing is trying to make prototypes again. And these prototypes may need to be industrialized in some way, because we have a lot of ideas. We have a lot of needs to be addressed. And when you put together people with a simple need and people that may have a different perspective, the idea comes out very naturally. But actually, what we could do is just making some of the steps for the industrial process, and we need some partnerships for going to the market. And this is something that we should learn, because this is not our job. Questions from anybody? Mario.
Where are you? Congratulations. Now, my concern about that is who is taking care of the machine during the operation? The radiologist, the surgeon, both?
Usually radiologists can control the images during the operation time in the operating theater, but I think that new figures can do this type of application. A 3D specialist is a figure that is a new job in the biomedical field, but I think that can be useful in the operating theater for this type of application. Thank you.
Okay, if there are not any more questions, let me introduce Vincent. Vincent is a very nice person. He's an engineer, again, and he's dealing with artificial intelligence applications in intensive care. We met together 2 days ago, actually, and we discussed about applications in intensive care, but he must tell you a story that might be even more interesting. Vincent. Thank you. This is the remote control.
Thank you, everybody. For the people on YouTube who have not visited Bambino Gesù, these people don't brag very much about where they work. I've had the luck as an engineer to work in healthcare for a little while, and specifically in pediatric healthcare. And I have to say that their hospital on a hill between St. Peter's and the Tiber River, and the passion with which they work is unparalleled. And thank you so much for having me over here, because it's truly inspiring. So I'm a software engineer. I moved to Houston for love. My wife is American-Mexican. I'm from Canada. And I looked for jobs, right? And it was all oil and gas jobs. And as a software engineer, you maybe don't want to work in oil and gas. A lot of my friends do. They're great people. They're probably better software engineers than I am. But when I saw a job listing to save lives with JavaScript, I was like, this looks like a joke, but I'm applying for this job. So I work for a company called Medical Informatics. We write clinical software that records time series data off of bedside devices. We keep this data forever in full resolution. And then our hope is to build more and more predictive algorithms based on those data sets, right? So your Philips, GE, Draeger devices at the bedside, right now most of that data is not being recorded, and much less is it available for the great people like at Bambino Gesù to do research and then to deploy products, right? Because it's great to publish a paper, but then you want to be able to apply that. So that's my job. I write software to help and do that. So why do we do this, right? Why do we want to apply artificial intelligence to clinical workflows? This is kind of a dystopian slide with this robot. The new movies have like a nicer looking robot for the nice guys. So automated diagnostic is a very important one, right? So you want to teach a machine to recognize patterns and hopefully to augment or make those diagnoses earlier. You want to automate workflows. There's a lot of things that happen over and over again, and there's no reason that a machine can't learn those simple things, and then people can focus on what they're good at. Earlier detection of deterioration, right? So before you can recommend a course of action, which I think maybe machines will be able to do someday, but to start, the first thing you need to do is to teach those machines to recognize at least the simple patterns that you could explain to somebody like me, right? So then I can write a program that can recognize that same thing. And then hopefully you get, as a doctor, to spend more time with patients. I haven't met a doctor yet that told me I'm afraid to lose my job. They all tell me, yeah, this part of my job is boring. Can you get a computer to do it for me? And so we're all hoping to get better outcomes and have more rewarding work. My work is super rewarding, but as a clinician, I know that there's a lot of parts of your work that's maybe not as rewarding as it should be. So where are we now, right? There's a lot of press on this right now of big companies like Google putting in a lot of money and effort into this. And they're doing amazing work. So right now we're seeing a machine identifying cancer at least as well as a human, right? They do this by using fancier math that I can use. I mean, they are Google engineers after all. And it's great, and it's using a single data set, right? So this is using images, identifying cancer. This is a similar example with time series data, right? So instead of having a picture of a cat or a dog or a cancer, here I have a series of events. So it's much more like the stock market, right? And as people who work with software and who work with math, they are completely different things, right? In one you have a T0, T1, T2. In the other case, you have like a huge matrix, potentially a 3D matrix that identifies a single point in time, but then you're having your dimensions be an image. In this case, your dimension is your time, right? And same kind of thing. A bunch of fancy engineers took this open data set and identified arrhythmias better than any human can. Pretty cool. There's a lot of noise at the bedside monitors, right? They don't identify arrhythmias as well as they could, so it's encouraging to have people work on just like EKG leads, right? Like, let's figure out these arrhythmias better. So where do we want to go from here, right? Like, we have an image data set, we have a time series data set, and we're doing machine learning on these things. We want to go from people at Google doing these things to you guys doing these things, right? Like everybody in this room has an idea of a pattern that they want to teach a machine, and they should get to do that if they want to. It should be easier. And then once you've published your paper, right, you've proven within reasonable doubt that this is a thing, and you found out how to, predict that a patient is going to deteriorate, you should get to deploy this thing. And I think Alberto and the team are doing great work to try and get these ideas out of a paper or somebody's head and back into clinical use so they can save lives. We want to apply this to not just the patients, but we want to apply this to other problems in the clinical workflows too, right? So I think taking notes is especially painful. Luckily here, I don't know, maybe somebody in the U.S. is going to give me hell for this, but I am Canadian after all. You have to document things a ton. And ideally it's to help patients, but in a lot of cases it's to bill. If these things are necessary based on your policies or your government, it should at least not be painful for a doctor. That's my opinion. Just I hope that at least machines can listen to people's voices and document workflows. And then apply this technology in a transparent way. I don't know if you guys have seen on Facebook when they tag your face. It's kind of unsettling, right? Like if at least in your clinical workflows it wasn't just, oh yeah, this kid's gonna die. Like you have to have an idea of why the machine is telling you this thing, right? So transparency is massively important, especially to start with. I mean, maybe the machines will get good enough that we'll just trust them, which is scary too, but before that happens, we definitely want to know why they're telling us the things that they're telling us. So the things that I work on a lot as a software engineer is to integrate these data sets together. So right now, like I was telling you, the big device manufacturers, that data goes and gets stored for maybe 72 hours. In a lot of cases, it doesn't get stored at all. But you want to tie it all in together, right? So it's maybe boring to you guys. To me, it's fascinating, but it's very important to be able to tie all these things together. And then once we do tie all these things together, I showed you earlier the sort of image data set, and we have the time series data set, and there's genomics data set, and there's all sorts of other data sets. When we get all these together, there's going to need to be new math and new research done so that we can build prediction algorithms based on all these other data sets as well. Okay, so the first slide was a Star Wars slide. We're actually Star Trek nerds in our company, Medical Informatics, so I had to throw it in there so that I wouldn't get home and they would give me hell. So as appealing as all that sounds, I'm not a dragon slayer, right? So what do we need to do to get there, right? How can we all get together and slay this dragon? So this is what I do, right? We record ECG data, lab results, event data, medication administration, ins and outs, flow sheets, EEG, and room sensors, right? So all time series data, T0, T1, and then you build a sort of stock market predictor, but based on patient physiology. And sadly, you're usually trying to find out when it goes down the stock market, not up. To do, right? So things that we're looking to do in the hopefully near future is how do we integrate DICOM images in there, right? How do we add genetic data in there? How do we add environmental data, continuous at-home data, right? Because there's data being produced by everything. And my hope is that all these data sets get integrated somewhere publicly accessible and patient accessible. Like, let's say I was born at Bambino, Gesù. I had a little Bambino Gesù watch, and it was pushing my data back to Bambino Gesù, and I had my little Bambino Gesù algorithm that was, watching me in real time all the time, and then I had too much gelato, right? And I have issues, I shouldn't be eating that much. So I've been doing that, by the way. If I had a Bambino Gesù watch, it would be telling me. Then ideally, Bambino Gesù would, send me a little nice message and say, hey, Vincent, take it easy on the gelato. And then my doctor would read that too, and the next time I went in to visit, they'd be like, yeah, you stop going to Rome so often. I want to come back. Anyway. And hopefully, too, from an ethics perspective, right? As a patient, I could be like, okay, I want all my data now, and it'd just be pushed to my own repository of data, and hopefully all that learning is used so that everybody wins, and not just, a few corporations, or gets locked down into a publication and nothing happens for it, right? The goal is to spread that as widely as possible. Oh yeah, the other thing I deal with is red tape, right? Because as a small company, the first thing people tell you is, nah, that's not possible. You're not doing this, right? This data's never gone anywhere and you're not recording it. And the second thing they tell you is, okay, now I believe you that you're able to do it, but the second thing they tell you is you're not allowed. And then you get a bunch of like motivated people, like the nice doctors I've met at Bambino Gesù, and they tell you, okay, we're going to scream until we get this done, and then we're going to do it, right? And once you've cut through all that red tape, but it takes a few great hospitals sort of leading the way so that other people can follow. Why it matters, I just wanted to put in some concrete examples from people that you might have heard of. This is an algorithm that uses 2 time series data points, your arterial blood pressure and your intracranial pressure. It does a linear regression. For those of you who don't know linear regression, it just tries to draw that line in there, right? So it's finding the line that's the closest possible to all the points. Right? And what that tells you is your brain auto-regulating, right? As you're pushing blood into the brain, is it doing what it should, or is it potentially hurting you, right? And I don't know what to do from there. That's somebody else's job. But I know that using the data set that we are collecting in real time, you get to do stuff like that, and then a ton of other things, right? Why it matters, another concrete example by Ken Brady as well, is my patient going to arrest, right? So you're getting a variety of different data signals, and what this is showing you is just at time 0 is when you have your arrest, and this is an algorithm that's giving you a risk of that arrest. So you can see as you're getting closer to that arrest, the certainty of, yeah, this is really not good is getting greater and greater, right? This is one example, and there's a bunch of risk scores out there that are not used as clinical devices, the PIM scores, the PAUSE score, all of these different things. The idea is we need to build these scores in a more accurate way so that we can predict these deteriorations, right? And ideally using all the data from all the places to make that as reliable as possible. Other ideas of why it matters, and I'm hoping to have a more open conversation if there's anybody on YouTube or anybody in the room who wants to bring their own ideas. Did my arrhythmia drug work? So we did a super simple study at Texas Children's where Dr. Valdez just had a bunch of Solol administrations, and he wanted to know, did my Solol do what I expected it to? And in a lot of cases, especially in pediatrics, you guys have to use things off-label, right? Because you want to save a life, but the company might not have approved this drug for pediatric use, so you're using it. And so having that data gives you confidence that you're helping the person, and having that data might help get regulatory approval in the future as well, right? So there's a bunch of reasons why unlocking these data sets matter. Is my patient fluid reactive, right? So having your arterial blood pressure combined with ventilator waveforms or other things allows you to answer these questions as well. Is my patient getting injury to the head, right? Is blood flowing properly to my brain or other parts of my body? Can I detect sepsis earlier? Right? Everybody talks about sepsis, but right now, if you're based on an EMR workflow, you're using old data, right? You're using old validated data, which is great, but ideally you would be able to build algorithms that just work on their own and alert people without creating much noise. How much nitric oxide should I give, right? So this is getting pretty popular, and it's helping with a lot of complicated cases. But, how much should I give? How often and why? Right now, those data sets are not available yet. So unlocking those data sets are going to allow people to hopefully make more progress on that. And then some simple problems that we worked with at the inception of the company is, am I driving my patients crazy with noise? So you put a microphone in a noise, you push some time series data, you record alarms, and then you just get the statistics of, is this absolutely impossible for patients and for families and for nurses to survive? And then how can I tell my story with data? That's actually one of the favorite parts of my job. I get to sit down with nurses and doctors, and they pull up the data, like not just I'm telling you a story, but here's all the data forever. And people who used to get into fights now get along a lot better because there's an objective truth in front of them, and it's not. The problem of narrative is not as important, right? Because you don't need to be a good storyteller, or you don't need to be as good of a storyteller. You can just pull up what you feel, and there's the conversation. And I just wanted to show a picture of my kids because I'm here with my wife and family, and I'm very lucky. I know that you guys work in healthcare too, but sometimes I go home and I hear about things, and you go home, you hold your kids, and you just feel lucky. And I just wanted to bring that up, and I think about it every day because it motivates me. Thank you so much, everybody.
No, thank you so much, Vincent. That was inspiring and also touching a lot of points that we usually discuss about the use of artificial intelligence in healthcare. One of the open questions is how much predicting has an impact on the final outcome of the patients. I think this is a fascinating story, but again is one of the things that we should be very careful about, because we are not used to this kind of tools. We must study more and more, because we didn't have any educational background on artificial intelligence and prediction and this kind of tools in our educational program. And this is extremely important, but because these systems might really make a difference in the destiny of our children. This is one of the things. Thank you so much. So we're moving to another topic, which is also very, very important, because is something about the direct involvement of children in innovation. I have the pleasure of introducing Begonia Nafria. I hope she's connected. Begonia, are you there?
Hello, good afternoon to everybody.
Begonia is a patient.
Can you hear me?
Yes, absolutely. We can hear loud and strong. Yeah.
Thank you.
Begonia is a patient advocacy manager. She is based in Barcelona, and she is in the hospital San Juan de Deu, and she will tell us something about the direct involvement of children in the process of innovation in that hospital. Begonia, the mic is yours.
Thank you very much for the opportunity to explain our experience involving young people in innovation and also in different kind of research initiatives. I'm going to share the screen. 1 minute.
You have about 15 minutes. Remember.
And you see my screen now?
Yes, we can see everything.
Perfect. Thank you. As I said, for us it's a great opportunity to explain the work that we are doing in San Juan de Deu Children's Hospital. This is the largest pediatric hospital in our country, but this movement about the involvement of young people in clinical trials and also in innovation, it's happening in other countries around Europe. And for me, it will be a great opportunity also to explain what is happening in the European environment. For us, it's important when we talk about pediatrics to consider that historically this group of patients, and you know well as me, being considered a vulnerable group of population, it means that historically they are only have been considered as a subjects of research, but not as an active members in all the process to perform a research initiatives. When we are talking about research initiatives, the concept that we have in pediatrics and in this movement of young advocates, it's considering different kind of projects, obviously clinical trials, but also innovation and other kind of initiatives like basic research. It's very important that we consider that we are working in this environment with many things to face, and the challenge is here, but also we consider that involving children and young people is the best way to solve this challenge and also these ethical considerations that in the past we never considered when we involve the patients, or in this case the children, in research. The first thing that I want to mention, and this is a fact, is that the 50% of the medicines that we are prescribing in the pediatric hospitals have been never tested with these patients. It means that the number of clinical trials or the research initiatives in this area are quite small for the needs that we have. But this data changes a lot if we talk about the premature neonates. In this case, the data is 90% of the drugs that we prescribe for this population, we never test with them. Obviously, in this case, it's not feasible to involve the patients for the age condition, but there is a way to gather the needs of the patient and the family, because at the end, when we treat a pediatric patients, we are treating the whole family. In this case, it's involving the parents. There are different ways to include the voice of the patients in pediatrics, and this is something that also I want to explain to you and encourage to do it. The other thing is that when we are talking about pediatric conditions, basically we are talking about rare diseases. 80% of these diseases that affect children and young people are rare conditions. It means that in the majority of the cases, we don't have a common treatment for them. And basically, the unique opportunity that we have to treat these patients are the clinical trials. It means that the group of young patients and their parents are a very well-engaged group. It's very easy to work with them. And probably if we lose this perspective, that at the end, even if we are working in basic research, we are working for the patients. If we lose this perspective, sometimes it's so complicated to develop patient-centric initiatives. This is something that we have heard a lot in the last years, but sometimes the concept that we have is that involving the patients in one of the stages of the drug development or regarding innovation of the cycle of innovation, it's enough, and usually we do it in the last stages. But for us, a real patient-centric initiative means involve the patients from the very beginning, also when we consider the unmet medical needs that are around. Other features that we need to face when we are talking about pediatric clinical trials and pediatric research is that in some cases the protocols that we receive come from the adult setting. In some cases, these protocols have not a pediatric version. It means that it's so complicated to find the right patients, and the design that we have of these studies, it's not feasible for the children. Other things that we need to face is when we are talking about young patients. Sorry?
Begonia, we can see just only the first slide. Are you moving on?
Okay. Sorry.
Thank you.
Let's try again to share the screen because... My apologies.
No problem. This is something that happens sometimes. Okay.
Can you see now the slides?
Yes.
No.
Go ahead.
Okay. Sorry. Other important features that we need to consider and to face when we are talking about pediatric research, it's the biology of the patients, because you know that they are growing and it's so different a child with 7 years or with 17. And other point that is important is the adherence during the study, because in some cases we don't consider that they are teenagers, that they are in the school and other features, and sometimes this is part of the success of the study that we are analyzing. Also, as I mentioned, when we are talking about pediatric patients, we are talking about the whole family. And it means that when we refer about the quality of life, when we refer about the outcomes of this study, it's very relevant to have this wider concept about the family of the child. And the last point that I want to mention is about this non-feasible inclusion and exclusion criteria that we need to face many times. You can see there are many challenges on the table, but I think that the right way to work in the right direction and to solve this challenge is working with the patients, because it's so easy to have a fluent dialogue with them, adjust our projects and work for the success of them. For us, the right way to approach and to solve the patient perspectives and the patient's needs is with the young patients advocacy groups, the YPACs. The first one was established in Liverpool in 2006, and at this moment are YPACs around different countries of Europe. These groups are groups of teenagers. It depends on the country. They start to involve children in a specific age. For example, in the case of our institution that it's based in Spain, we start to involve children with 12 years. This is the age in Spain where it's mandatory to request the assent of a patient in a clinical trial, and we consider that this is the right age to involve these young patients or young people in these groups in order to include their perspectives and their needs in the different projects in what they provide advice. For the success of these advisory groups, it's crucial and essential the training that we deliver to them. This training in our institution, it's focused in 4 pillars. The first one is to talk about biomedicine. It means that we need to explain to them that there are different kind of conditions that affect children, in some cases only children, that we have different methods for the diagnosis, different kind of treatments, etc. The second pillar is about, in general, clinical research. They need to know how it works. They need to know what means a protocol. They need to know, obviously, to understand what means this patient-centric design. The third pillar is about clinical trials. It's very focused and specifically addressed to cover all the technical points in what we expect to collect their feedback. And the last and fourth pillar is innovation. Innovation because you know that there are innovative treatments, but there are around at this moment many initiatives focusing the development of medical devices, APPs, and other kind of tools that are addressed for the patients. And also the success of this patient-centric design comes when you request the advice of these young people in the very early stages of the development. Also, beyond this advice and beyond this citizen science training that we can provide to these young people, we consider that the impact of this involvement in these groups affects other phases of the life of these young people. We consider that we are not helping them probably to live a healthy life. They share the training and the knowledge to their colleagues in the school. And also some of them, when they become adults and they need to decide about their future occupation, some of them we have the experience that they have moved forward to the scientific setting and started the university in the medical school or other kind of careers related science. This is the current map of the groups that are working at this moment in Europe, and a small group of these YPACs founded 2 years ago a YPAC-net. This is the European Young Persons Advisory Group Network. We have new teams. One is in process here in the Bambino Gesù Hospital. We have another team in Bari in Italy. We have a new team in Belgium. It's not in the map, but also Germany, Finland, that you can see in the map. It means that thanks to the dissemination and the awareness that we have worked so hard within these last 2 years, we expanded this model. We have explained to other pediatric hospitals that this is an advisory group that helps a lot to have these patient-centric initiatives. We are also very happy to have the recognition of EMPRIMA, the European Network of Pediatric Research Initiatives from the European Medicines Agency. And it means also that we have the voice of the young people and the children in the regulatory setting in Europe. The future, how we envision this new landscape of pediatric clinical trials and also innovation in the pediatric setting. For us, it's very crucial, the celebration of the 10 years of the pediatric regulation. We participated on behalf of EYPACnet in the workshop that was held in IMA. One of the important outcomes of the discussion that was held there was about the importance to standardize the consultation of patients and young people in all the steps of the medicine's life cycle. This is crucial for this patient-centric development of initiatives, and also it's essential to work hand by hand with the sponsors, because not all the initiatives are led by academic institutions or pediatric hospitals. We need to work with the different kind of sponsors, and also consider this ethics perspective that the ethics committees provide to the projects. This is in the roadmap and in the agenda of the European Medicines Agency and the European Commission for the upcoming years, and it means that from the regulatory point of view, it's going to be promoted this way to develop science and innovation involving the patients. Also, I'm happy to explain to you that in the European Medicines Agency last year, 2 teenagers were involved in a scientific advice of the PDCO, And in the upcoming future, we expect that this will be one required step of any project that will be assessed from the members of the PDCO. What we can do from the point of view of innovation, education, and involvement of children and young people. As I mentioned, it's very essential, the education of the patients. And one important activity that we can do with them is the development of these informative and educational resources for our patients. This can be using friendly formats like the comic that you can see in your screen. This was developed by our YPAC. We created with our young people the script. They decided what were the 8 main concerns that the young people need to face when we are talking about clinical trials. Obviously, the first one was to know what is a clinical trial, because probably never you have heard about this until the last time that the doctor suggests to you to be involved. But also they suggest other additional 7 topics. They decided the cartoons, they decided the atmosphere and different scenes of this comic. These pictures are based in the real world of our hospital, in the different facilities. And the most important thing is that using the patients and this friendly way that they want to access to this information, we designed this comic that you can read as a whole story, or you can go directly to the page where the topic that is interesting for you it's included and access to this information. So we have the experience to develop innovative tools for the education of the patients. This is an IPP that we have in the waiting room of the clinical trials unit. It's a big tablet where the patients can interact and know more about what means a phase 1, phase 2, or phase 3 or 4 trial. They have different activities to check if they have achieved the knowledge that we expect about this. And nowadays, this is a tool that our clinicians are using when they need to explain to the family and to the patient which are the features of the trial in what they are invited to take part. We have other educational resources and activities in the website of our team. And also, for us, it's very important the involvement of the patients in other kind of innovative projects. The YPAC Kids Barcelona is linked to the clinical trials unit of our hospital, but also to the innovation department. The same methodologies of involvement that we have tested for a long time in the participation of patients in clinical trials also can work for innovation projects. In your screen, you will see the pictures of a session that we did with our members about an APP to educate the young patients with language problems. They choose the name of the avatar, they choose the right avatar, and also they provide advice about the different scenes at the adventures, because at the end this is an APP that has a lot of gamification. For us, it's part of the process that we follow with the different innovation projects in our hospitals. And it means that we have the opportunity to collect their opinions and feedback in the very, very early stages of the innovation process. And this ensures to us that we are in the right direction and we are considering the needs of the young patients. If we don't do this, it's sometimes so difficult to have this approach, because as you can imagine, the professionals involved in these projects, we have the bias of the background, technical or scientific, but also the age. And I think that it's part of our team. And in fact, in Sant Joan de Déu Children's Hospital, Kids Barcelona were recognized as a young person scientific council of the institution by our CEO, and they have the official status in our hospital as volunteers. They meet with us once per month in the Friday afternoon. Other kind of innovation projects in what we are working with our YPAC is related to this new environment about the electronic assent. You can see in the screen, and this is the outcome of a survey. The patients prefer the use of the electronic tools. They prefer the format that is friendly for them, even to access to information about the very important decision to take part or not in a trial. And this feedback, if you can see the outcomes of this survey in your screen, also it's very aligned with the feedback of the parents. And in this sense, we are going to pilot in the upcoming months an electronic assent with the aim to try to change the process that we are following to inform the patients. We still receive very long protocols, obviously very long assent documents and consent documents for the parents. The idea is to create something friendly, directly to the point to the points that are interesting for the patients. But in any case, with the flexibility that the electronic tools can provide to us, to include a glossary, a video, infographics, or other kind of format, in order to facilitate a very target process to inform the patients. And last, I want to focus about the scope that our group has beyond the activity of the hospital. For us, the dissemination about the activities that we are doing in research and about the involvement of patients is crucial. And in this sense, every year we perform a conference during the European Week of Science to disseminate all the projects in which the Young Persons Advisory Group have been involved in the last year. And in this screen, you can see a summary about the collaborative work that we are doing at the European level. Our aim is to create awareness, but also change the mindset of the different stakeholders. It means sponsors, investigators, regulators, or ethics committees. We have at this moment this small network that the name is WIPACnet. From San Juan de Déu Children's Hospital, we are the single contact point of this network. And the idea is to provide this feedback from the WIPACs to all the projects that can be interested to access to the network, and probably they don't have the right resources or the capabilities to include the feedback of the patients directly in the projects. We can commit a feedback report of our activities in time between 2 or 3 months, because usually these teams, as I said, meet one per month or one per month and a half. So this is a last slide that summarizes different activities that we can do with patients regarding clinical trials. As you can see, and as I mentioned at the very beginning of my talk, patients deserve to be in the very beginning of the drug development process. They can help us to identify these unmet medical needs, but they can help us also to design the protocols. But also in the last stages, it's very important to involve them in other kind of activities like the life summaries, that it's something in what we are at this moment investing a lot of time and energy in order that this dissemination about the outcomes of research also will be friendly and accessible for the patients and their families. And this is my presentation. I will be very happy to answer any kind of questions that you can have. Thank you.
Thank you, Begonia. So I think you also discussed several of the points that we are discussing together in our hospitals and together with you, even in the frame of international activities. Working with children is exciting, is sometimes amazing, is funny, but most importantly is something that we absolutely need for addressing their needs that sometimes are completely under-recognized or not recognized at all. That's one of the things. And they can work with us, simply, and we just have to accept. I hope that we will work together in the near future, because we have very interesting plans. And I'm moving to the next presentation, since we are trying to stick to the agenda and the times. The next presentation is a nice story about how a clinical need has been addressed by simply searching for a technological solution among different startups. I'm the pleasure of introducing Sylvie Donaldson. Sylvie is from a European consortium. The consortium is eHealth Hub, and she will tell the story. Sylvie. You are muted, Sylvie.
Hi everyone. Yes. Can you hear me properly?
Yes.
Okay. So
Sylvie,
thank you
no
for
more
your
than 15
invitation,
minutes,
and good afternoon, everybody. So my name is Sylvie Donasson. I partner with eHealth Hub to promote innovation in healthcare and support the development of startups in the field of digital care. And today I would like to tell you the story of Bambino Gesù Hospital with eHealth Hub initiated some months ago. The challenge started with establishing clinical needs together with Professor Tozzi and the team of neurosurgeons. And as you know, shunts malfunctions have very various symptoms and really depend on specific cases and situations. And talking together, it became rapidly obvious that a remote monitoring system could be of tremendous help for neurosurgeons to detect chance problems. So express the need of the hospital or for clients, more generally speaking, in a way to attract best startups, make the message clear, simple, easy to understand for them, but at the same time matching perfectly the expectation of the stakeholder is something we always spend a lot of attention and a lot of time on, and it's what we did with the team. We really, took time to discuss in depth the need. Then must-have requirements for the foreseen solutions were specified in a brief, tested with a couple of startups before to be spread out. In that case, a solution including patient records, a series of information and measures like picture of the child, morphometric measures, clinical signs and symptoms, and so on and so forth, but also algorithm able to provide alerts to patients and healthcare professionals were defined as key to have. And, the challenge to address is associated with economical benefits for the hospital and the healthcare system more globally, knowing that in the future the solution could be also implemented outside of Italy. So the project with the hospital is a very ambitious project, but it's really worth to invest in terms of research, on time, and on cooperation with startups. The first step of this process, defining the needs, defining the requirements, was also the opportunity to think out of the box and work on what we call not only the must-to-have, but the nice-to-have requirements. What can be done differently or better, or what can we do more additionally to deliver better than initially expected. How to define the best partner, the ideal partner, what kind of business relationships are possible. The more you think in advance, and the better the outcomes of the whole process. Having a strong and clear brief document in hand to communicate to the startups. A call for application has been launched to our database, gathering more than 70,000 contacts across Europe and over Europe, and the desktop research performed additionally to the call. Thanks to a very strong communication campaign, including the use of social medias, a real significant number of solutions have been identified matching the needs of the hospital. Something I would like to stress on is that in our process, we really use a method making us able to compare one solution to another, which is usually an issue, for hospital or other type of a profile of clients. When they are contacted directly by startups, there are a lot of difficulties to benchmark and know exactly what makes difference between one and another. So it's something we solve, and we are very strong on in our processes. So 7 startups were finally pre-selected, and we started the conversation with. And finally, 3 of them, a French one, a Finnish one, and a startup coming from the UK, were invited to Rome at the beginning of May for a live event meeting. This event was really the opportunity to share the information, to invite the team of neurosurgeons, but also other healthcare professionals from the hospitals, to sensitize the managers' direction to the innovation and what can be done to improve not only hospital practices, but also patients' monitoring and outcomes. And the conversation will now continue between the hospital and two of these startups to co-design, to validate, and to implement new solutions, short and longer term. And this, what we call solution match process, we are able to deliver it, to manage it in 3 months, depending, of course, on our client constraints, but we can be very efficient and reactive in the process. So we finally. HealthHub is a consortium of 9 companies with different expertise in digital healthcare, complementary to each other, located in different European countries. So you have the list of the partners here. What we offer is a series of services tailored to clients' needs, punctual or strategic. We can help them all along the business journey with market intelligence, planning, communication, connection, implementation, including advices on best business and collaboration models. Over the past year, we demonstrated our capability to support hospitals, insurers, pharma and medical devices company in France, in Spain and Italy, in the UK, at different steps of the innovation strategy already. We are very passionate people, as you are, about healthcare and innovation, so probably, many reasons to partner together. To give you some facts and figures, our strike force combined with our expertise is one of our major strengths, with 20,000 eHealth Urbers, 16,000 followers on Twitter of eHealth and affiliated companies, and quite numerous events already successfully set up. So do you want to start pushing innovation in your strategies and, duplicate the story according to your needs that we performed with Hospital Bambino Gesù? You can contact Aline Noisette. She is part of the call today. Aline is more especially in charge of health business development, while personally I manage services delivery, but we work as a team together. Thank you.
Thank you, Sylvie. I love this story because it was one of the first examples in which we started from a clinical need and we found a solution through this process, which is not common. Actually, we came out with a lot of different solutions that we didn't think about. For example, for the solution that Sylvie was describing, we didn't know that there was a company trying to develop some specific sensors for measuring pressure inside the nervous system, which is something completely breakthrough, breakthrough innovation possibly in the management of this kind of patient. Thank you so much, Sylvie. We hope to have the same process for a number of different clinical needs in the future. You know that we are connected, and we look forward also to meeting you in Helsinki next week. Thanks a lot.
Okay. See you in Helsinki. Thank you, Alberto.
Let me introduce another special friend. We have Roberto Ascione. Roberto, he is from healthcare, but there's a special reason why I want to introduce Roberto. Can you hear us, Roberto?
Hi, Alberto. I can hear you well.
Okay. Please give Roberto a round of applause because yesterday he became a dad.
Thank you, Alberto. Thank you.
And this is the first time that I see a lecture from the meeting room of a clinic. He is speaking from the clinic, which is special. Thank you so much, Roberto. Roberto is giving us some flavor of the topic we'll be touching in a conference, which is digital therapeutics with challenges, opportunities, discussions, and so on. Roberto, please.
Thank you, Alberto. I can see myself on the screen, and I'm about to share my charts as well. As you can probably see from the background, I'm in the beautiful town of Naples, which is my hometown, and we're at this Mediterranean clinic exactly yesterday. The little Antonio was born. So let me share my screen. You should be getting now my first chart. Yes, I can see that. Okay, so what I will be doing, we'll talking briefly about the digital therapeutics as a preview of what we will be discussing extensively in October at the main conference. As Alberto was asking, just a brief intro about myself before getting started. So I'm Roberto Ascione, I'm CEO for Healthware. Healthware is a company, international company, started in Italy, present in the US and in Europe. We focus on digital health transformation through multiple different areas, ranging from communication strategies to innovation management, up to building of digital health solutions like digital therapeutics, for example. So digital therapeutics are very much in the news these days. These are titles or quotes taken from not even specialized media, but from kind of general mainstream media, so to speak. So Forbes, The Economist, and so on and so forth. As well as one of the most important investors in the digital space, venture capital. There's a general agreement that this is something that is transformational for the practice of medicine. So we will define better what the digital therapeutics are, but this should be seen as a subset of digital health, which is, of course, a bigger segment encompassing quite many aspects. Digital therapeutics are a basically specific domain of digital health, and we will go straight into the definition in a moment. But let me take just a step back and basically define where digital therapeutics start as a mode of action, so to speak. This is the study, or this is taken from the study of WHO about the determinants of human health. And what this study basically tells us is that a number of conditions, more than 60%, 65% of human conditions, are not related to genomics per se, but are rather related to a number of aspects which touch basically unrelated to biology side of our lives. Our education level, the access, we have the material access that we have to health systems, our income and social status, and many others. Basically, technologies and digital therapeutics specifically have the power to really impact on all these aspects. And this is where digital health in general, digital therapeutics specifically, really take origin in my opinion. So digital therapeutics, this is the definition that is fairly well accepted globally and was mainly defined by the Digital Therapeutics Alliance, are basically patient-centric, and super important to start with this, so that these are patient-specific, patient-centric solutions, which are either software alone or software plus drug interventions that are able to basically provide a positive, clinically measurable, and of course a scientifically validated effect. So it's not software applied to medicine. It's not anything digital health. It's specific solutions which have been validated these days almost like drugs, so through randomized controlled clinical trials, and so that are basically proven to be effective in a clinical setting. There are over 170, probably now close to 200 digital therapeutics companies out there, mostly, of course, startups, although some are kind of grown up and starting to be sizable, like Omada, for example, that I can mention on the diabetes side. And this market map, as they are called, is gently provided by Digital Health Network, who are great partners of us. And as you can see, they span in a number of different areas. Clearly, CNS, everything that can be modified through behavioral-driven interventions, cardiometabolic, are all areas where digital therapeutics are quite strong. Rehabilitation is another one which is quite interesting. And as you can see, there are really several areas and more are coming up. All this to say, these are specifically geared towards several medical domains, while the mode of actions can be different. Can be behavioral modification, as mentioned, could be virtual augmented reality, multiple ways of being active, again through software principle, which is the real novelty of this approach. As an example, this is a Healy, Boston-based company which use gaming as a way to basically stimulate the specific regions of the brain. And what's important of this company is that has reached the FDA clearance by successfully completing the pivotal trial last year in the ADHD disorder. So in the deficit of attention, this has been proving successful compared to the standard of care that exists so far. So once again, clinically validated as a drug, but is a software. And it specifically, in this case, is a game. Aside of the vertical solutions for this or that specific condition or disease, also platforms to orchestrate those interventions are increasingly important. The one that I'm sharing right now is instead Italian. It's called paginemetiche.it. It's a company that basically created a platform to orchestrate and connect patients, physicians, and services. In this case, why is it relevant for digital therapeutics? Because they are starting to orchestrate the access to digital therapeutics as part of their process. So a couple of key players worth mentioning. The Digital Therapeutics Alliance that I mentioned before is a basically global association that connects together on one side the startups that are developing this space and the large corporations like pharmaceutical companies, medical device companies that are looking at this area. The other organization I would like to call out is Frontiers Health, the conference, which I'm chairman for, that since its inception 5 years ago has a specific track on digital therapeutics. And I like to say that this conference is a close partner to shaping the future of pediatrics. And with Alberto, we are doing more and more together to connect these two ecosystems. One other area that I like to mention, and again that through the Shaping the Future we will be expanding more and more, is that digital therapeutics are basically leading to the emergence of new partnership opportunities. In this specific case, I'm kind of showing what a pharmaceutical company can do with digital therapeutics companies and what they can bring respectively to the table. One of the themes for the upcoming conference, both Shaping the Future of Pediatrics in October and later on Frontiers Health in mid-November in Berlin, will be exploring what these new partnership models look like, because there is a general I would say consensus that digital therapeutics startup companies are able to provide that fresh thinking, innovative solutions, and potentially larger scale established life sciences companies can help with the distribution, the diffusion, the access to large scale number of patients for these solutions. So we believe there's a lot to explore into the partnership between these two worlds. What we do on digital therapeutics, and again, this will be just an anticipation of what we will be discussing more extensively. At Healthware, we have a comprehensive attention and focus on digital therapeutics, which goes from helping different parts of the ecosystem to identify the opportunities and the cases for digital therapeutics, the design and application, to the help with building together with either startups or large-scale corporations, as well as to invest in digital therapeutics. We run a early-stage investment practice which does invest in mainly digital therapeutics and a digital health platform. So for anyone that is interested in digital therapeutics, please do get in touch, and there will be a lot that we could discuss potentially between now and when we will meet in person in October. I would like to wrap my presentation up with a concept that I really strongly believe in and that I explore also in my book, The Future of Medicine, which is digital health is not about digitalizing or even worse, I would say, transforming medicine into a tech play. It's rather the opposite, is to leverage and use technology, different kind of technologies, whether they are data-driven technologies, machine learning, design, VR, whatever, into applying them to what we know today as healthcare at large, to basically do a couple of things. Improve the care opportunities we can deliver at the sustainable cost, so to enlarge and maximize access on one side. And on the other side, I like to think that with the usage of those technologies, we will be able to free up time for our physicians, our nurses, our healthcare professionals in general, so they could spend more time to engage, empathize, interact with patients and their caregivers, which is something that the technology will never be able to do, but the technology can save a lot of time, can do a lot better, a number of things that now we use humans to do. So with this, I believe right on time, I'll thank you very much for your attention. You see a few references to get in touch, and I'll return the line to Alberto. Thank you.
Thank you, Roberto. If you never attended Frontiers Health, believe me, this is a very nice conference and is surprising for some different reasons that you will discover if you come to the next edition. Thank you, Roberto, and congratulations again. Thanks.
Thank you so much, Alberto. See you soon.
See you soon. So, we're coming to the very last presentation. I believe that we have Alessandro Ranellucci connected with us. Alessandro is taking us back to the very first presentation that we had. He's one of the organizers of the content of the Maker Fairy, one of the largest fairies for inventors. I'm following the Make magazine, which is a magazine for inventors, since a lot of years, and it's really fun. So, Alessandro, if you can give some flavors, you have the last presentation, so you have not to go for hours, but actually everybody is waiting for some of the information about the Maker Fairy in Rome, because this is the largest in Europe, right?
Yes, exactly. It's the largest in Europe. Can you hear me, actually?
Yes.
Perfect. And don't worry, my speech will be short. So thank you for the opportunity to speak at this conference. There are so many high-level people that are doing actual innovation. And while working with makers, I've been involved in innovation projects for many years, and shaping the future is common to almost all fields of research, business, and human activity in general, of course. In this conference, you are discussing the future of pediatrics, and at the same time, there are people discussing the future of agriculture, the future of archaeology, and so on. But this is not, I think, just a matter of researching and looking forward, which is natural, of course. This is triggered, in my opinion, by a very special historical time when some things are changing. And one of these is the availability of new technologies. And the content of the presentation in this conference, of course, confirms this. But another important change is their accessibility. Technology now is easier than before. People can access tools for creating technological things. Artifacts are easier to create. Electronic devices can now be built, to some extent, of course, even by people who are not electronic engineers, thanks to Arduino and other platforms like that. Mechanical devices can be 3D printed. Data can be analyzed because machine learning tools are relatively easy to learn. And don't get me wrong, please, as I'm not advocating that experts are not needed anymore and that academic education is obsolete. No, I'm not one of those people who think that Google replaces knowledge. I'm trying to tell another point. I've been seeing that in the past 10 years, millions of people with no specialized education have been able to create electronic and mechanic artifacts that were previously impossible to create without access to professional tools and skills. I said millions just to give you a figure. The Arduino community involves about 30 million of people around the globe. And these people are creating new things, physical things, physical artifacts. These people often start from personal problems. Solving your own problem has a way bigger value than finding a pre-made solution. And since we are talking about healthcare, helping beloved people designing and making something for them is invaluable. I've seen so many makers gaining happiness by adopting that process and doing things with their own hands. So healthcare, quality of life, disability, apart from the clinical definitions, disability is not an absolute status. We are able or unable to do something according to a given context. Everyday objects, furniture, or architectural barriers, or digital interfaces make each one of us more able or more disabled, including me, including all of us. In some things we are disabled people because there is something that doesn't let us do what we want. So makers hack, modify, improve their everyday life, their tools, their context, their environment, and they experiment with new ideas or solve their own problems by learning, prototyping, sharing. And these are probably the most distinctive cultural traits of the maker movement. I mentioned Arduino. Most of you know it's an electronic platform's prototyping board. I mentioned 3D printing. There are also 3D scanning, open source communities, and other things, including the FabBob network. More than 1,200 of laboratories around the world now share a common set of tools and collaborate in making digital fabrication accessible to local communities. And then we have maker fairs. So Maker Faire is a global network of events where makers meet and showcase their inventions to the public. And Maker Faire Rome is the largest maker fair in Europe. It has a comparable size to the largest one and the most known one in San Francisco. And actually Maker Faire Rome is the one that is most focused on innovation. Innovation in terms of potential products, business opportunities, social values of what people bring to Maker Faire, and so on. We have been working on this for 7 years. So next October, from the 18th to the 20th, we will have the 7th edition of Maker Faire. And every one of you who hasn't been there in the past editions is invited to join this event, because you will see people trying to solve these problems, and people are researchers or passionate hobbyists or startups or universities. They're all together, close one to each other, and regardless who you are, regardless who they are, these people are showcasing their solutions and their ideas. In the past years, we have been working with Filippo, Cipriani, and Sanofi in a very successful initiative called MakeToCare. You probably already mentioned, which highlighted tens of very high-level solutions that are very customized and very, very open and available to inspire other people. This is a very important initiative that shows how the maker approach is complementary to the market, because sometimes the market is not able to customize solutions, while people in this field need their solutions. So all these projects are very good examples of this. This year we are going to have so many new initiatives that I don't want to steal your time by listing all of them. I will mention one, a new thing we will have this year, an initiative called Ask Me Anything. We will have makers answer questions by people, by visitors who want to use their knowledge about electronics, prototyping, mechanical design, and so on, and makers will be available with their knowledge. So this is a new initiative of this year. And one last thing I want to tell you is that the call for makers is open. You will find the deadline and the details on the website of MakeToCare Rome. And call for makers is the way makers propose their ideas for the next edition of Maker Faire. And we say that everyone is a maker, because everyone has the ability, the potential to solve some problems, share their knowledge. So I'm sure that all of you actually fit somehow in this broad definition of makers. Also, we all know people that solve problems with a lot of with good ideas and by following a learning by doing approach. So I invite you also to spread the word among all the people you think would fit in this category, because MakeToCare Rome is the place where actually we bring to Rome people from all over the world. And I will say one last thing. Last year we had projects from 61 countries. So it's a very international event where actually innovation is communicated in a very informal and open way. So I think that's it. So thank you for your attention.
Oh, thank you so much, Alessandro. I must tell you that we did not talk together, but actually you repeated some of the words that I was telling before, because the idea of prototyping or coming from a need and complementing the offer of the market and shopping is one of the ideas behind the maker movements. But I think that one of the most interesting things that you said was everyone is a maker. I believe so, and I think that we should be convinced that even physicians that are mostly resistant to doing practical things may be convinced of that. So I hope to meet you soon, because I think that there will be a lot of links between the Maker Faire and also what we are doing for the innovation process, but also for the conference in October. The conference will be also immediately before the Maker Faire, so there will be a lot of links between us. And thank you so much for being with us and for concluding this short meeting, for giving you a flavor of what we are trying to do. I must thank you, all the attendees. You were patient enough to stay with us for 2 hours and a half, and we tried to put together most of the ideas that will be also presented in the conference in October. I hope that you perceive that this will be not only a conference, but this will be a process, because we will be trying to develop all the ideas that may match a clinical need for our patient, and this is the basic thing that I think we should address. With this, I invite you to register to the conference. The registrations are open, and I hope to meet you as soon as possible at Bambino Gesù and possibly at the conference in Rome, which will be at Piazza di Spagna, Roma Eventi, from the 2nd to the 4th of October. Thank you so much, and have a nice day. Thanks.